This is John Black, Super Chemist. I just wanted to go over a couple things I want to do for when I start my channel back up. I already have a bunch of videos, well, at least a couple, that I started and I didn't finish. So I'm going to tell you about those. Sulfur purification, how to crystallize it. And I know a million videos have been done on that, but I'm going to do it anyways. Nitrite. Nobody's done anything on nitrite. I'm going to do that. I'm either going to make it from N2O3 or, where you bubble it into the sodium hydroxide, or I'm going to, another way is, and this is in Wikipedia. I finally found out where I read that. The first guy who made, I think it was either sodium or potassium, I'm pretty sure it was sodium nitrite. All he did was he took some sodium nitrate and he heated it until it was red hot, and he kept it there for 30 minutes, and that's how he made it. Now, is it pure? I doubt it, but that's another method. It's nice, easy, where you don't have to do anything. I'm going to give it a try. Um, Phosphorus, I want to do that. I'm not going to do it from matches. I want to do it from sand, coke, and phosphate, the way they originally did it, the way the guy originally did it. Make your white phosphorus and bubble it into some water. Red lead, I already mentioned that. I want to do that so I can break diols and make aldehydes. And there's so much stuff you can do with this. It's unreal. Uh, Mellow yellow, I just want to make it because it's a dye and it looks cool. Um, but these videos, I pretty much started them already, including this stuff over here. I, the way you make an aldehyde is get an you can oxidize an alcohol to an aldehyde, and you can oxidize an aldehyde to a carboxylic acid. Now, I only have three alcohols, obviously, methanol, ethanol, and isopropyl alcohol, right? Gasoline antifreeze, drinking alcohol, rubbing alcohol. So you can see, if you oxidize it, you can go up to formaldehyde, formic acid. This one goes up to ethanol and ethanoic acid. This one is in the middle, see, so you can't get a carboxylic acid. It'll go straight up to acetone. These I kind of started. I have three main things I'm going to try to oxidize them with. One is chromic acid, permanganic acid, and bleach. And I have a couple other ideas, but these three I'm definitely want to see what they do and how much percentage yield I can get. Another thing I'll be doing is I'll put a padlock into some copper sulfate and see how long it takes before the padlock disintegrates. I'm also going to get a chain link fence. And I'm going to spray copper sulfate onto it and see if it dissolves the fence where I spray it onto, like on TV with 007 type crap. We've all distilled methylbenzene or toluene, whatever you want to call it, out of stuff, paint thinner, whatever, auto parts cleaner or whatever. I want to actually make it. Now this is how I'm going to do it. I'm going to make some toluic acid from mixed xylenes. Now I only have one xylene here, but it doesn't really matter. I'm going to have mixed, and I'm going to put dilute nitric acid as my oxidizer, and you can see I'm going to reflux it for a long, long time. That's going to oxidize one of these methyl groups to a carboxylic group, right? Now, the reason why it doesn't do both is because this is not strong enough. See, this is an electron withdrawing group, and so it's going to prevent this from being oxidized, the second methyl group. And if you wanted to oxidize the second methyl group, you can put a catalyst in and it'll do it. But if you leave the catalyst out, you'll end up with toluic acid. Now, it doesn't matter where this methyl group is. It can be here, 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 wherever. Because in the very next step, you're going to do a soda-lime decarboxylation. Basically, you've all seen people do this with benzoic acid, and they heat it up with this pyrolysis, and you end up taking this off and getting benzene. Well, we're doing the same thing. The only thing is we want to take that off, and the methyl part will still be there, so we'll end up with methylbenzene instead of benzene. So it's a nice little reaction. I couldn't figure out how to do this without oxidizing both of them, you know what I mean? But that's the secret. Use this and don't use the catalyst. And that way it will oxidize only one because this is a electron withdrawing group. Now, I have some nitromethane, and I'm going to, everyone's seen aniline, right? Or you get your nitrobenzene and you do this and you make your aniline, right? Well, I'm going to do it. This is how you're supposed to make a primary amine. You're not supposed to make it from ammonium chloride and formaldehyde. This way you only get a primary amine. Okay, this is primaries. When you do it the other way, you get dimethylamine, you know what I mean? You get trimethylamine. This you get only one because there's only one nitro group to be reduced. You can't add on other methyl groups. Same way with the Hoffman rearrangement and this here. You're just basically taking out the carbonyl group. If I covered up the carbonyl, that's what you got left. Cover up the carbonyl, that's what you got left. And also, with you can do this basically with phthalimide too, and that way you make a primary amide. But I'm going to do this one because Bayer's reagent to make 1,2-diols. Basically, we're going to make these double bonds. We already made propene in a video. We're going to make ethene, and we're going to make polystyrene, or I mean the monomer of styrene. Those double bonds we're going to turn into 1,2-diols, as you can see. Then I'm going to take those diols and I'm going to do a pinnacle rearrangement. That's how you make aldehydes and ketones. The 3 diols we have, if you use dilute acid, you'll get the aldehyde, which would be acetaldehyde, propanaldehyde, phenylacetaldehyde. And if you use concentrated sulfuric acid, you'll get acetone for here, and you will get methylphenyl ketone. I see people doing Grignards all over the place. I don't see anyone doing them with a methyl group. You know what I mean? Methyl groups, methyl bromide boils too low. I mean, it's a gas at room temperature, but you can cool it down a little bit and it'll be liquid, you know, a little bit below room temperature. But nobody does it with that. And I don't know why. Probably because it's a gas. But I'm going to figure it out and do that. I'm going to take methanol, make my methyl bromide, make my Grignard reagent. And here's a few of the reactions. Formaldehyde, acetaldehyde, and acetone. I'll react them with all those and get these products. Drinking alcohol, ethanol, isopropanol, and I really want this tert-butyl alcohol. And also I could use CO2 and make acetic acid. Anyways, that was just to give you, I'm going to also do an ethyl group on here. Try to build up make some fatty alcohols. But I am going to figure out Grignards and do a lot of Grignards. Hopefully they won't be the same Grignards as everybody else. People always say, well, why don't you just use a methyl iodine and make a Grignard reagent? Then it'll be a liquid instead of a gas. You won't have to worry about it. Well, my thing is iodine is expensive, man. I can't waste that much iodine. Iodine has a molar weight of 250 grams per 1 mole. That means that, and I need at least a mole to do. Let's say I do 10 experiments and they're all 1/10 of a mole. That's the minimum I can do. I mean, if I can't get that much, there's no sense in getting it. And what is it? You buy a bottle of tincture or the providone, and it's what, $10 a bottle? You get like 2 grams out of it. I mean, I figured it out. It's going to cost me $1,000 to get a mole of iodine that way. I ain't doing that. No. Bromide is easy. It's, you know, sodium bromide and some sulfuric acid. Both you can buy right at the store. All right, now I already said I'm going to make a primary amine, methylamine, this way. Another way I'm going to do it 2 different ways. The most famous way is reductive amination. Everyone knows it from you're going to make the drugs or whatever. But I'm just going to make methylamine with it. I'm going to get formaldehyde, ammonia, make my imine, and then my imine, I will take mercuric chloride, which is basically uh, an aluminum, and I'm going to make a aluminum mercury alum. I forgot to put the aluminum on there, and heat that up and change my imine into an NH2. If you look at these, look at both of these things. If I take this double bond and I open it up, right? I take one up here and I put an H on there, and I take this one down and I put an H on there. That's all I did here. Because this C has two H's. This C has three H's. One H, two H. So I added an H on both sides of the double bond. That's it. And that's all basically reductive amination is. Now, if I started with, instead of formaldehyde, I started with acetaldehyde, then I would end up with ethylamine. And if I started off with butanol, I would end up with butylamine. But these are great ways to make primary amines. I wanted to bring this up because, I don't really bring up, I don't know, safety features, I guess, a lot. But I brought up the SO3. I thought I should bring this up just in case. It's called alpha explosion. Heating a crystal of alpha sulfur trioxide to its melting point results in a sudden increase in vapor pressure, enough to shatter the glass containing the SO3 being heated, um, which is what is known as alpha explosion. Um, so I mean, if you're doing stuff like this, you got to start out simple. This is on you to figure out the safety stuff. I'm just making videos showing how I do it. Um, so keep that in mind. A lot of things can explode that you don't even realize. Another thing is I'm going to make some SO3 sulfur trioxide. It's a solid. And I see people making sulfuric acid all the time, bubbling SO2 into, what is it, into the hydrogen peroxide. And that does make sulfuric acid. But once that runs out, then you're left with water and you're bubbling SO2 into water. Now you're just making sulfurous acid. And my belief is that after over time, that will convert into sulfuric acid. So it'll all be sulfuric acid eventually. But you're not really, especially if you use if you don't use 30%, you use 3% hydrogen peroxide, that's nothing. You're basically making sulfurous acid. Um, Now, if you put SO3 into water, what happens is it's supposed to be really exothermic, very violent. You're not supposed to do it. You're supposed to actually put it into concentrated sulfuric acid, and then you dilute the oleum down to sulfuric acid. But I'm going to do a little experiment. I'm going to put some SO3 into some water. Let's see how violent it is. I don't think it's that violent if it's small. It's not like I'm making 20 gallons of sulfuric acid. Uh, so let's all just see, because I am so curious. How violent is it? Obviously, I'm going to do some BS experiments, general chemistry type stuff, and uh, some other stuff that I haven't mentioned, maybe even some repeat stuff that other people have done. But I do have a million other things. I don't think I'll have enough time after all I've just said, plus some of the other stuff I want to do that I put in my other agenda videos. Um, I think I would love to do some enol chemistry, maybe an alpha addition to a carbonyl, uh, something like that. You know what I mean? Aldol, not nitro aldol, maybe a Claisen condensation, maybe one. I just have too many experiments I'd like to do. I'm also going to make a full t-shirt into nitrocellulose and wear it while someone lights it on fire. I'm going to make some uh, gunpowder and some nitroglycerin. I'm going to take some methyl ethyl ketone and I'm going to make acetic acid or ethanoic acid out of it. Um, that's the formula. I'm running out of time. So I'm going to end it with this. And always remember, science is great.